So this worksheet is now a little bit different. Instead of doing some theory and writing some formulas, we are going to do some practical stuff. We had looked at how to represent feature models in propositional logic in order to analyze them using a SAT solver, and the front end for a SAT solver that we used was Limbool. So we were writing these propositional logic formulas for Limbool and then analyzing it using Limbool. Now, what we're going to do is, instead of writing always the formula for the feature model, we're going to try to write a program that takes any feature model as input and writes out formulas that then Limbool can analyze. And we write the formulas in a specific way so that the output of Limbool will be the result of an analysis. So this is what we're going to do here. There are two tasks. The first task is we need to implement the translation of feature models to formulas in proposition logic format. If you maybe remember the slide from the last exercise where we said, well, if R is the root feature, then the corresponding formula is simply R. If P is a parent feature of a feature C, then it means that having the child implies having the parent. So this is the table that we had in the lecture and in the exercise of how to translate. There are a few maybe not that trivial things in the translation. So of course, this relation between parent and children and parents and mandatory children, that's quite straightforward and very local. The bit more tricky ones are the OR groups and XOR groups. So the alternatives and the exclusive alternatives, because then here really for the exclusive alternatives, you basically have to say one of the child features in the XOR group is true while all the other ones are false. And you have to do that for every single child. So that's, well, if there are n children, then you will have a disjunction of n possible combinations where one of the features is true and all the other ones are false. So it's not that bad, but it requires a little bit of thinking how you're going to implement that. Now, of course, you need to implement this in some context. So whenever we want to automatically analyze some representation of some software, this could be code or software models, like in this case, the feature models, we need a representation, an abstract syntax representation usually of the models that we want to translate, the ones that we want to read, and we need to bring it to some format, which is like the output format. In our case, the output format is a formula for in Limbool syntax. And then the next step would be we call the tool Limbool. And for example, in this first case, we would use this for checking whether a feature model has at least one product. So we would do consistency checking using this translation. If we find that this generated formula has at least one satisfying assignment, so if Limbool says, yep, this is satisfiable, then we know that the feature model is consistent because it has at least one product that we can configure from this feature model. But there's some machinery required, and this machinery is given in this code. So let's download this code and then import it in our IDE. So here I'm going to use Eclipse. We also tried Visual Studio Code, so multiple, basically almost any kind of IDE you want should work. You should have a Java development kit installed, a JDK. Otherwise, you might have some problem building the project, but yeah, we'll see. So then let's say we're going to import the project. And here I'm going to choose Gradle, existing Gradle project, because the project is a Gradle project. So you could even just build it without an IDE. If you don't have this option of importing an existing Gradle project, then you might want to go to Help, Eclipse Marketplace, and then, so if we just type Gradle and search, maybe that's already going to give it to us. Okay, here it's not the first one, but it's down here. Build ship Gradle integration, that's the one here. You see it's already installed in my Eclipse, so I don't have to install it. But we knew that because I already had this entry here when I say file, import, and then Gradle, existing Gradle projects. So now we're going to import the Gradle project. So as Gradle, existing Gradle project, next. Then I already unzipped the archive. If you clone it, you will also just have the project. I unzipped it with a subfolder, so that's a bit annoying. Now you really want to be in the folder where you see these files. So let's select this folder where we see the source and the Gradle folders. Otherwise, it will be nested. The project would be nested. So this would not look as nice. So let's say finish. Now it looks good. This was really fast. That's the project. And we can have a look at just checking whether everything compiles. So there is a very simple printer example that's also mentioned in the worksheet. We can try to run this as a Java application, and it prints a feature model. That's the same feature model that is described in the README here. So if you run this printer example, then you should get this output. Now there's another thing we need to set up. Depending on what kind of machine you're on, there is this Limbool executor. So we will use Limbool now not on the web as the web interface, but we will use a binary. But this binary might be different based on the machine you're on. So if you're on a Linux or Windows or Mac computer, it will be different. So let's find that. This is in this other package here that's called feature models exeg. There's Limbool executor. And then you see that because I'm here on a Windows machine, I have this limbool.exe. Now, if you're on a 32-bit Linux, you use this one. If you're on a 64-bit Linux, you use this one. If you're on a 64-bit Mac, which has some Intel CPU, you use this one. If you have an M1, you probably have to compile Limbool for yourself. So check with us how to best do that. You will simply comment out the line of the Limbool that you can't use and comment in the line of the Limbool that you want to use. So if we were on a 32-bit Linux, we would use this one. Yeah, but I'm on a Windows, I use this one. And then you can, again, this Limbool executor, that's a file you can try to run. If you run it as a Java application, it simply takes this formula, passes it to a process call of Limbool, and then prints the output that this is an unsatisfiable formula, right? So if we would say A and run the same thing again, then it would say it's satisfiable, and the satisfying assignment is this. So this basically is the code that we will use to invoke Limbool based on some formula in the format of Limbool. And